Linh-chan and Dimi-chan, write code. Just wanted to make more room. Anywho, we will go and make a similar method that's actually going to do the reading and writing of the video. Start asset reader and writer, and we're gonna have an error callback as we did before, just in case there are any errors. And then we are going to go ahead and use this right here. So self start asset reader and writer, and then we're going to catch the error if there is one. So do you remember you're reading about the error handling?
Mm-hmm.
This is basically the Objective-C version. So if anything wrong goes, anything happens while it's trying to change the video, like the video has some broken frames in it or anything, it will push that error up so that way you can hear about it in your side. So now we're going to start the asset reader and writer. So we want a bool to indicate if we were successful equals yes. Success equals, so we're going to start reading from the asset reader. And what this is going to read, start reading. So what this is going to do is it's going to basically start getting video from the file. Turn success. And if we're not successful, so then we will push the error out so that way we can hear about it. Equals asset reader error. And then if we are successful, we can actually go and start using what the reader is giving us. So actually before that, we do want to start the writer. So we'll do the same thing. Success equals asset writer start writing. If not success, then we're going to do the same exact thing. So I'm just going to copy paste. And then now we're going to start doing the work. Success. Let's start our dispatch group. Do you remember we had a dispatch group, which is going to basically consolidate all our queues. This group, there we go. So we're going to make a new dispatch group. Dispatch, I guess it bailed on me. Oh, there it is. Group create. So that's our group, and we are going to say, tell our asset writer to start at 0, basically. So video files are weird such that they don't technically have to start at 0, but for what we're doing, we want it to start at 0. I guess maybe if you want to continue writing an existing file, that could be useful. I'm not too sure though. And we're going to set our flags that the audio finished and the video finished to no, because we will be changing these shortly. And now let's grab from our audio. So if there is an asset writer audio input. So only if there is audio, then we're going to do work with audio, basically. So dispatch group enter. So we're going to go inside of our, we're basically going to say that any work that's going to happen now is going to be part of this dispatch group, such that when it completes, we can tell the dispatch group that we're done. And then when all the work on all the queues that have submitted information to the dispatch group are done, the dispatch group can say that, hey, everything is done. And this will give us a nice way of consolidating everything. So now asset writer audio input, request media data. So we're going to request stuff on the audio queue. This will happen separately from the video queue because not everything is organized nicely in video files. And if the audio is finished, we're just not going to do anything, basically. But until the audio is finished, we are going to just forward all the information from the original file to the new file. So completed or failed equals no. So now we're just going to loop through all the information that we can get at this time, and then this will be called repeatedly, essentially, as more information becomes available. So is ready for more media data, and we didn't complete or fail. Then we are going to get that media data and do something with it. So core media sample buffer, reference sample buffer equals asset reader audio output, because we're dealing with the audio, and we're going to copy the next buffer. And then we're going to do something with that buffer. So if the sample buffer does not equal null, so we're in CLAN now, so we can't compare to nil anymore. We'll check if we were successful. Successful in appending the samples. So asset writer audio input, append sample buffer. So we're taking the buffer from the reader and we're putting it in the writer, basically. We're passing it as is, and then cf release. And then we're going to release our sample buffer because we don't need it anymore. And C is memory managed, where Objective-C is automatically memory managed, but it's not garbage collected. So you can still run into like retain loops and stuff like that. But here we're in CLAN, so we do need to release our memory after we use it. Otherwise, we're quickly going to use lots of memory. And then we're going to null out our sample buffer so we know it was successful. Equals null. And then completed or failed is going to be set to not success. So if we were successful, then completed or failed is no. If we were not successful, completed or failed is yes, because we failed, essentially. Else completed or failed equals yes. So if we completed or failed, then we gotta do fun stuff. We can check if it was finished. So first, let's check if it was finished previously. So we'll say old finished equals audio finished. And then audio finished equals yes. And then if we didn't finish previously, so this is the first time we finished, then we can mark it as finished. Otherwise, we don't want to mark it because that could cause some problems later on. So we want to say mark as finished. And then we want to leave the dispatch group, which will notify us that the work that we did was successful, basically. Dispatch group. So that's our work for the audio input, and now we're going to do something very similar for the video input. So I'm just going to copy that entire thing and make changes. So this one's the video. We do want to show progress, so I am going to add a few extra things here. So I'm going to have a block hold, not a block, so basically I'm going to have a variable right here that's going to hold the last percentage percentage that we showed in the user. So we don't want to like update on every frame because that's going to be a ridiculous amount of updates on the user interface. We just want to update every 200th of a frame, or every 200th of the whole thing. So that way we don't necessarily overwhelm the user interface and slow down our encoding, because that would not be, we don't want to spend more time updating user interface when we can spend that time actually encoding the video. So let's get the total time of the media that we can then divide. So self.asset.duration. And then whatever the last percentage is, if it grew by a certain amount, then we'll notify. If it didn't grow by enough, then we won't, basically. So asset writer video output this time. Then the video is finished. We want to be on the video queue. And then here we want to be on the video queue again. Video queue, video output. So we're doing the same exact thing. We're taking the buffer from the output and we're putting it on the input. And AV Foundation will take care of the rest. But before we actually do that, we do want to update our progress. So the way we'll do this is we'll get the current percentage. So ns time interval. And I'm using ns time interval here because it's related to time. Even though I'm working with like a percentage, it is a double, so it's just for convenience that I'm calling it ns time interval, so I know a little more what it is other than just a number. So let me get the seconds of the current buffer. So our CM sample buffer reference will tell us where it is in the whole video file. So we can say sample buffer get presentation timestamp and sample buffer, and then we can go ahead and divide this by our duration, and this will tell us what the current percentage is. So if our percentage is bigger than the last percentage we saved plus 0.5%, then we can go ahead and change it. So last percentage is now going to be equal to, so I'm going to round it to the nearest second percent. So 0.5%, I mean. So percentage times 200, and make sure that's a floating point number, and then divided by 200. So I'm rounding it, I'm multiplying it by 200, I'm rounding it, and then I'm dividing it by 200 to make it a fractional number again. And since it did change, we are going to notify the main queue, which has the user interface, dispatch as async, dispatch main queue. So we're going to notify the main queue that our progress changed. And this should update the progress bar in the queue such that we can see that progress. So now we just need to make sure it says video everywhere. So let's see. So the sample buffer is null, video here. This needs to be video. So the reason why I'm not using the magic arrow at this point is because I don't want to change the audio stuff up above. I just want to change it right here. So that should be all of it, I believe.
And we're done?
And we're not done, unfortunately. But now we can do the work where... Did I miss something? Maybe if I missed something. Oh, yeah, I did miss something. So if success. So we should only do this if we were previously successful. I was like, I'm one What just happened? Oh, there it is. I was one indentation off, so I was a little worried that I did actually miss something. So now we did complete both, or we want to be notified when we completed both the video and the audio. So we can say dispatch group notify. So let's specify our group, dispatch group. We want to do this on our main serialization queue. And this is the work that we want to do. So let's have a flag to mark our final success if we are successful or not. This error, final error equals nil. So if the asset reader dot status, so if there was an error with the asset reader, AV asset reader status failed, then we want to say that we failed. Final success equals no final error equals asset reader dot error. And if that failed, we want to stop the writer because we're done writing. So if it succeeded, we want to stop the writer. That is because we want to tell it that we don't have any more frames to write. So finish writing with the completion handler. Now if the asset writer dot status equals AV asset writer status failed, then we are going to notify our reading and writing that we failed. So we finished successfully, no, sorry, with this asset writer error. Dot error. And then otherwise we didn't fail, so we're going to say we finished successfully. Self-reading, yes, and no, because we don't have an error. So that is what happens when we're successful, and if we failed, then we're going to do something else. And basically, we're going to just say that we had an error, and this is the error. So we'll pass our final error right here, and that is the error of the reading error that we created. So I believe this is most of it to get everything hooked up. So let's see what happens. All of that just to resize a video.
Seriously.
Craziness. Okay, so if we say small, when I say open, the job should start, and it crashed.
Did not.
And of course the open dialog is like right there. So let's see what might have gone wrong. Okay, asset writer input contains one or more invalid keys. So, do you remember what I said before about these being nitpicky? This is what I meant. Okay, asset writer, video settings. So it is not expecting the color primary keys. So we'll comment these out for now and see if that improves the situation. So let's say small. And there we go. So our encoding failed, and we indicate that. So that's cool.
Oh, did you set it up like that?
No, but we set it up to indicate if there's a failure, and it did fail.
Oh.
So it tells us that there was a failure.
Why did it fail?
It failed because the video settings were invalid.
Oh, okay.
So
because you comment all those things out?
Yeah, probably. I'm going to try just to, like, I don't know what's missing here to make it happy, because I actually am trying to do like an intermediate step of before we do all the resizing just to get everything working. So to get that working, let's just go ahead and just say nil here and see if this works, to just see if we have any good progress, and then we can write that next step that actually does the resizing for us.
Another time.
It still failed. You want to do it another time? We're almost done.
All right.
Yeah, I swear.
I got lost like halfway through. So like an hour ago, I got so lost.
Okay, so let's finish up the last part right now, just so that way we can get it over with, and then we don't have to get too lost ever again. So basically, we want a way to specify like which part we're cropping and all that, and we're going to do all of that in more or less one step. We want to eventually know what the original dimensions of the video are, so let's have a property that's going to remember that. So this is going to be non-atomic.
Do you need to specify what the dimension is, or does it automatically know?
It's going to be useful if we ever get to the point where we want like a user interface to like click and drag like what part we want to crop to, that we know what the original size is, so that way we can like adjust the numbers according to that. So this property is going to hold the size of the video. So track dimensions, and then we want other properties that are going to essentially give instructions of how to re-encode the video. So property non-atomic double maximum video bitrate. So this is the video quality in kilobits per second, which is what most people expect to be giving. We want a boolean for the crop, if we should crop the video or not, or just resize it. We want an NS color for the background, because otherwise it's going to be green. Color. We want a frame width and a frame height. So NS integer frame width. I guess this can be a CG size. Height. So this is the width and the height of our final video that we want. And then we want two rectangles, which we're going to use for cropping. So CG rect source rect. So this is going to be the rectangle of the footage we want to keep, so what we're cropping outside of it. And then destination is where we want to place this footage on the new larger image.
You have a comment. This person said it helps a lot to see you debugging as you go.
I'm glad, because it's unexpected debugging at this point.
It's a learning process, definitely.
Yeah, so I guess this is better than just showing something that works on the first try, because in real life programming, nothing works on the first try. Yeah. So you do need to kind of debug on the way. I would have liked to debug this problem to get it working at that stage, but I fear that that's just going to take hours, and I don't want to just spend hours. So I'm going to continue and do like the full thing, and that will fix it in the end.
Well, I'm sure there's going to be many more chances later on when I try to attempt converting this Objective-C project into Swift. Mm-hmm. And for me, it's going to be a really big challenge, since I'm just starting to learn Swift. Mm-hmm. So there's going to be many chances for us to see the debugging in action. Yeah, like in real time. Yeah. 1 hour later. And of course, Dimitri is going to be helping me a lot with this. And we're going to be doing this later on, you know.
So here I'm just setting a default maximum video bitrate. Maybe that's a lie. I'll just leave it. Good quality is a good thing. And then let's set up our track dimensions that we talked about earlier. So this is basically going to read the track dimensions from the video file. So we're gonna get an NS array for our video tracks. Video tracks equals self.asset tracks with media type AV media type. So again, we just want the video tracks. And then AV asset track asset video track. And at the very least, when you're translating this from Objective-C to Swift, you don't necessarily need to know how any of the video stuff works because all the instructions are there. You just need to translate it.
Yeah.
So that should be a lot less debugging on your side as well. Because I already spent a few hours just getting this working. So we can skip that step. Asset video track. So if we don't have a video track, then we're just going to say that our video size is 0, or 0 by 0. That's what size is. This is a width and a height. So there's a size 0. That's the same thing. So we're just going to use that. Now let's grab the video size from the video itself. So format description. So we're going to grab it from the core media buffer. No, so we need to use core media types, which don't make any sense, but that's okay because the internet helped earlier. And again, as a developer, never be afraid to consult the internet or consult others because there's no way that someone can be a professional in everything. I have definitely gotten a lot better at dealing with video related stuff because of what I do at work. But don't be afraid to consult other people's work to see how you should do something because it's definitely tricky and it's not necessarily well documented enough where Apple just has like a class that teaches you how to use all this stuff, you know. So if we have video format descriptions, then format description is equal to, and this is when we need to do complicated stuff. We need to convert it, since this is a CF format description ref, we need to convert it to that. So walk bridge description ref, and then we will grab the description from this is a plural. From our array that we got it. And then you can just say that first in object. I'm translating in real time. Simplify. Okay, so we got that. Now let's just assume that our size is 0. CG size track dimensions. Dimensions equals CG size 0. If we have a format description, we'll use it. If not, we'll get it somewhere else. So sometimes the video can be sized independently of what the actual pixel size is. So it's important to check this first to see if there are any transformations that need to be done on it. Format description, get presentation dimensions, blah. Format description, and then false and false. So those are the options for the clean aperture and things like that. And then to flip 2 letters is Control-T. Always useful. Useful little trick when you are dyslexic and you type at random. Or you type faster than the computer and doesn't keep up and your fingers go in what order they want to. And otherwise, we're going to just grab a natural size if that one is not official enough, quote unquote. So that's going to give us return track dimensions. So that's going to give us the video size. And then we can go ahead and create our cropping information. This series was originally live streamed, so we split it up into 30-minute episodes so it can be uploaded. Since it does take more planning to make this kind of content, we don't plan on producing it very often, but if you do enjoy it, please subscribe on YouTube or Twitch and let us know in the comments below or on Twitter. Thanks! Bye, Chan-chans!